Hello, we're going to start Unit 2, Day 2. We are going to introduce polynomials and multiplicity, but before we do that, we're going to do a warm-up with factoring. Okay, if you remember the problems that are in the form ax squared plus bx plus c, we're going to factor these, but here in all of these, our a value is 1. All right, this should be a short factoring. If you know how to do it, please go ahead and do it. Honors, you really got to know how to do these without a calculator. I will show you guys with a calculator just quickly if you're having trouble with this. But you should really know how to do these by hand and should know factors of numbers. Okay, so like right here, when there's nothing out in front, we can create two parentheses, x and x. All right, and what we say, what are the factors of 5 that add to 4? Well, here, if you think about it, 5 is only 5 times 1. All right, so 5 times 1. Okay, so 5 times 1. Well, here I can only do this and add it, and I get 6. Or I can change the signs, but it would have to be changing both signs. All right, and that gives me -6. All right, because, and some of you may be thinking, oh, but wait a minute, I can do 5 and -1. The problem is 5 times -1 is -5, and that's not what I have here. I have a +5. All right. Yes, it does add to be that +4, but it doesn't multiply to be that 5. So guess what? I don't have anything. So if it doesn't factor, it would be prime. All right, so now let's go to this one right here. Okay, x and x, because there's nothing out in front. What are the factors of -24 that add to -5? When I do have a negative number, unlike this one, one's going to be positive and one's going to be negative. So just think about numbers that go into 24. All right, 1 and 24, just make sure one of them's negative. Okay, that would be giving me -23. Even if I flip-flop the signs, it would give me +23 when I added it together. So I know it's not that. All right, so 2 goes into here 12 times. Let's put a negative on 1. All right, that gives me -10, but I want -5, so it's not that. Even if I reversed it, it would give me +10. All right, 3. 3 goes in there 8 times, so I'll put the negative on the 8. That gives me -5. All right, that's what it adds to, so there we go. It's going to be a +3 and a -8, like that. All right, and that's how it factors. I can keep going through, but I found what I needed, and you need to do it quickly, okay? You cannot take all day on that. Now, if you're having trouble and you're like, but I don't know how you can get that and you don't know your factors, we can go to our graph right here and you can say, okay, x squared minus 5x minus 24. If you find the x-intercepts, -3 and 8, but think opposite. If that's -3, you're going to put an x plus 3. If that's a +8, you're going to put x minus 8. So think opposite on it. Now let's try number 3 without a calculator again. Okay, nothing out in front, so we're going to do x and x. What are the factors of 18 that add to -9? Now here, because 18 is positive, it means both of them are going to have the same sign. So let's see. I know 2 and 9, but when I add that together, that gives me 11. All right, 3 and 6. When that adds together, it gives me 9, but wait a minute, that's -9. All right, so what if I do this? If I want -9, but I got a positive, you just switch the signs of both of them. -3 and -6 gives me -9. And double check, -3 times -6 multiplies to be +18, but they add to be -9. So -3 and -6. And again, I can throw this into my calculator. All right, so let me pull that up right here. If I put in x squared minus 9x plus 18, I see my x-intercepts are 3 and 6. So here, think opposite, x minus 3, x minus 6. And there we go. So that's how you can quickly factor. And if you don't know how to do it with a or in your head, do it with a calculator quickly. All right, so now let's grab our workbooks and we're going to go to page 149. All right, 149. All right, so here we go. Let's look at just a couple problems here, and you'll see that I have a couple things written down. We've got two equivalent forms of a function. Identify the vertical and horizontal intercepts. Now, this book uses those. Please note, when they say vertical, vertical goes up and down. What's the vertical intercept? And I wrote this entirely wrong. This is supposed to be y-intercept. Okay, and what is the horizontal? Horizontal means it goes across. That is our x-intercepts. All right, on the EOC, it is going to say y-intercept and x-intercept. Don't know why this book does that. All right, but let's go graph these. So we want to identify them. All right, so 2x minus, whoops. All right, so 2x minus 1 and then x plus 2. All right, so here we go. Here I can see my y-intercept on this first one is at 0, -2. All right, x-intercept, all right, I actually have two of them. This is at -2 and that's at 0.5 is 1/2. So that's -2, 0, and then 1/2, 0. All right, so let's go graph this other one right here. Okay, 2x squared, okay, plus 3x minus 2. But wait a minute, what just happened to the other one? If you actually hit this button right here, the color blue, it actually, you'll see that these are actually the same graph. They just look totally different. So they actually have the same y-intercepts and same x-intercepts. It's just these things are just look different, okay? And what they've done here is they've multiplied this one out. 2x times x is 2x squared. 2x times 2 is 4x. -1 times x is -x, and -1 times 2 is -2. So 2x squared, these two are like terms, they make 3x minus 2. And so all they've done is they have just multiplied it out. It's the same exact function, just one of them's in factor form, the other one's in multiplied out. The other thing is this, when it's multiplied out like this, just know this right here. This is our constant. All right, but our constant is also our y-intercept, okay? When it's in factored form, we can actually see our x-intercepts, and we're going to be talking about that later on. So those are some things I want you to notice, all right, and to put into your memory bank. All right, so let's look at the bottom of this, and I'm only going to look at two of these, all right? Instead of doing which one doesn't belong, we're going to find all of these things. Now, one of the things that we like to do is make sure that these are in the highest degree to lowest degree. Now, you can plug it in your calculator exactly like this, but here I'm looking at the degrees. The highest exponent is 3, so I'm going to do that first, then squared, then minus 4x, and we always put our constant on the end. Just be careful, that's a 4. All right, so by looking at this, and here you should notice your constant is 4. So guess what? If our constant's 4, that should be our y-intercept, 0, 4. And we're going to verify that on our calculator right here. Okay, so let's go put it all in. So x cubed, and it doesn't matter which version you put in. Okay, so there we go. We've got it in, and we can verify, yep, 0, 4 is our y-intercept. Okay, so let's look at x-intercepts. I've got 3 of them right here. Okay, one of them is at -2, 0. One of them is at, whoops, 2, 0, sorry. And the other one is at 1, 0. So 2 right there. Okay, you can have multiple x-intercepts, but you're only going to have one y-intercept. Okay, relative max. When we talk about a relative max, we're talking about when it goes up and comes back down. All right, so right here is a relative max. Let me take all these other points off. All right, so I have a relative max at the point -0.869 and then 6.065. Some of those are nice and some of them aren't. Now, min is when it decreases and then it increases. So it's got this low point. It's not the actual lowest point on the graph because this keeps going, but we call it relative, all right, because it looks like it could be. So 1.535 and -0.879, like that. All right. When we ask for what is the degree of the function, we look for the highest exponent. So that is going to be 3 here. When we talk about leading coefficient, we think about the term that we just got the highest exponent on, and we talk about the number that's out in front. If there's not a number, that number is 1, and that's going to be our leading coefficient. So our leading coefficient for this one is 1. And now let's talk about our domain. All polynomials that we are talking about in this unit, the domain is -infinity to infinity. we're not limited on the x values that we can plug in. However, the range is going to differ. Now on this one, when the exponent is odd, our degree is odd, you're going to see one end go down and one end go up. And so that means this keeps going to negative infinity, that keeps going to positive infinity. So we're actually hitting every y value. All right, so negative infinity to infinity is our range. All right, so now let's talk about this problem. Let's talk about B. Write all these things out again. X-intercept, y-intercept, relative max, relative min. All right, we want the degree. Okay, leading coefficient. All right, constant. And some of these things we can find without a calculator, and I will in just a second. And then I will use the calculator to find the rest. All right. So as far as y-intercept is our constant. So what's our constant here? Right here. This is our constant. All right. It's 2. Okay. So that's our y-intercept, 0, 2. Another thing you can figure out is your degree. That's the highest exponent. Now this time we don't need to reorder it because it's in order. So the degree is 4. Well, here, go look for the leading coefficient. If I know this is the thing with the highest degree, then that's going to be my leading coefficient, the number out in front, which is 2. All right. Another thing you can figure out, because this is a polynomial, every polynomial, the domain is all real numbers, negative infinity to infinity. All right. So now let's go graph this. Slide that over so we can see both at once. All right, go put in. And guys, don't just watch me on the video. This is one of those things that you need to try for yourself, because eventually you're going to be plugging all these in to the calculator yourself on an EOC, and you're not going to see it, or you're not going to know how to do it if you don't practice now. So make sure anytime your teacher practices, we need you to practice as well at the same time. Here's our x-intercepts. They're not nice. It's okay. So 0.3840 and then 1.1180. All right, relative max. Well, do we have a high point here? No, we don't have a high point. Okay, so we're going to say none. Relative min, I do have one. Here's our relative min. It's at 0.8 and negative 1.101. All right, and now let's talk about our range right here. So our range, all right, if you actually notice down here, it's not hitting our graph at all, or our y-axis. It starts hitting it right here. Okay, now range is talking about the y value. So here we're going to do from -1, and this includes it, negative 1.101. And then these ends keep going up. So it keeps going up to infinity. All right, we're going to be continuing with polynomials some more. So make sure you flip it over and have your calculator ready. All right, so here we go. We're going to look at some more polynomials, but I want you to look at all of these. These are in factored form. Now, one of the things I want you to notice is here, let's find all the x-intercepts. So here I've got an x-intercept at -5. I've got an x-intercept at -1, and I've got an x-intercept at 3. I want you to look up here for a second. All right, one of the things you should notice is that when we say x-intercept and it's in factored form, if you were to actually take each of these and in parentheses and set them equal to 0, you would notice that when you solve, here I would get x equals -5. Here, when I subtract 1, sorry, I didn't leave myself enough room, I would get x equals -1. And here, when I add 3 over, I'd get x equals 3. These are all the x-intercepts that I have right there. Okay. Now, our y-intercept. Our y-intercept's down here. Now, we could kind of guess at what it is. Well, one of the things that we can do is, without actually multiplying all of this out, we can actually find our y-intercept. We can figure out what degree that we have as well. So if you take all of these constants and multiply it together, 5 times 1 times -3, guess what that's going to give us? It's going to give us our constant, or our y-intercept. So 5 times 1 times -3, and that gives us -15. Does that look like where it hit on our graph right here? And it does. All right. The other thing is finding the degree. The degree deals with the number of x's. All right. If I do x times x times x, I'm going to get x cubed. All right. So my degree is 3 right here. Okay, so let's go find them all again. Now, obviously, they graph this, but here, when it's in this form, factored form, if you do x plus 5 equals 0, x plus 1 equals 0, and then x minus 2 equal to 0, and you go solve these. All right, so I'm solving them real quickly. And to move them over, you do the opposite. All right, so my y-intercepts or x-intercepts are -5, -1, and 2. Doesn't that match what I have on my picture right there? Now, let's talk about our y-intercept. It looks like it's hitting at -10, but how do I get that when it's in this form? And I don't see the constant. Well, you multiply all these constants. 5 times 1 times -2. All right, and we get -10. That's where it's hitting, so that's our y-intercept. And our degree. Our degree right here, multiply x times x times x, and I get x cubed. So our degree is 3. All right. And we can do the same thing with this one right here, but I want to move on to page 151. But before we do that, I do have a question, and it's down here. What else can we call x-intercepts? You may have seen this in math too when you talked about quadratics, but x-intercepts are called roots, they are called solutions, and they are called zeros. The reason zeros, it's when our equation is set equal to 0. All right. If you hear any of these words, we're meaning the same thing, and we want to know where it hits the x-axis. All right, so let's look at a couple of these on 151. Find all the x values that make this equation true. All right, so here, if we just set each of these parentheses set equal to 0 when it's in factored form, whoops, that's -1 equals 0. Then we're going to find when this is true. So here I would subtract 4, x equals -4. Subtract 2, and I get x equals -2. And here, when it has a minus right there, add 1, x equals 1. So our solutions are -4, -2, and 1. If I were just to graph this without the y equals 0, I would find my x-intercepts to be -4, -2, and 1. All right. Now, here we go. Let's go do this one. Now, this one looks a little different because it has 4 factors for it. All right. Set each of these equal to 0. All right, and go solve. All right, so here the solutions are -4, -2, 1, and 3. All right. Now, one thing I want to talk about here is when I look here, I see that there's 4 x's, so x times x times x times x. This would be x to the 4th. This is actually degree 4, all right, on this one. All right, here, if I go back to number 1, do you see how x times x times x? All right, x, x, x. So here, this one is degree 3. Okay, now, this right here in number 3, do you see how I have a square right here? Really, this means 2 of the parentheses x plus 4 and 2 of the parentheses x plus 2. All right, but here I just need to set x plus 4 equal to 0 once and x plus 2 equal to 0 once. Subtract your 4, you get x equals -4. Subtract your 2, and you get x equals -2. But here, because I have an extra parentheses, really, -4 happens twice, and -2 happens twice. We call these double roots. All right, we'll look at these on graph in just a little bit. All right, but here, if you actually look, okay, because I would have x, 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 and x, how many x's do I have? I have 4. So therefore, it is degree 4. All right, and each time I want you to take a note of how many roots I had in the degree. All right, think about that for a second. All right, now here, if I want to find the roots or what this makes true, so 2x plus 8 equals 0, these are a little more complicated. These aren't as easy to solve, but we can still do it. Subtract 8 here first. And then we divide by 2, so x equals -4. Here we add 3, so 7x equals 3, and we divide by 7, so x equals 3/7. All right, add 10 over, and we get x equals 10. So our solutions would be -4, 3/7, and 10. And still look at it. Here, you would be doing 2x times 7x times x. So that would give me 14x cubed. Still, our degree here is 3. Now, our leading coefficient is actually 14, in case you actually needed to know that. All right, but look, 3 roots, degree 3. All right. Now, if you have trouble solving this, we can go to our calculator. All right, so let's graph this one right here. And you can actually, if you cannot solve this by hand, you can plug this in, 2x plus 8. And you could have plugged in any one of these as well, x minus 10, like that. And we can zoom out and we can see all three. This one's -4, which we got. This one is 0.429. So if we actually look at 3 divided by 7, there's the 0.429. And then here, this one is at +10, which is what we just got a second ago. The unfortunate thing is Desmos on this one, I guess you can write it as a fraction. The problem is this 0.429 has rounded it. So if you just plug it in there, it's not going to give you the correct fraction. That's the only thing with that right there. All right, so let's go and look at some more. Okay, so this one, when we go to look at it, all right, x squared minus 4 equal to 0. All right, add 4. So we get x squared equals 4. Now this one has a square on it. So we have to take the square root. But anytime we take the square root, we need plus or minus. So the square root of 4 is 2. All right, and that's actually plus or minus 2. So our two solutions are +2 and -2. All right, and then here it said x plus 9 equal to 0. And we subtract 9, and we get x equals -9. All right, and if you look here, if I do x squared times x, I get x to the third, so the degree is 3. Well, what's something that you've noticed about zeros and roots and the degree of the function? If you haven't noticed this already, the degree equals the number of roots. Even when we're up here in number 3, where we had the double roots, all right, I would have 2 of those parentheses. You could count each one of those roots. And so we had 4 roots in all, even though they're both double. And our degree is 4. And so the number of roots equals the degree. So keep that in the back of your mind. That's the possible number of roots that you can have. So if your degree is 4, you're not going to have 5 roots. You're not going to have 5 x-intercepts. So just know that the most is going to be 4 right there. All right. Another thing I want to make sure that we hit, because you may hit it later, is, all right, make sure you remember increasing, decreasing, x-intercept, y-intercept. So we just covered x-intercept and y-intercept right here, -6 and 2. All right, is our x-intercept. So -6, 0, and 2, 0. I am on page 154, just looking at one of these graphs. Now, our y-intercept, we don't quite know where our y-intercept here is, but it's somewhere in between 0 and 10. Unless they give us the equation, we actually can't figure it out. But we can tell it's a positive number. It's above the x-axis. So I'm just going to write this, between 0 and 10. Okay, now where is this increasing? This is really what I wanted to look at. Increasing is when it's going up. So here I'm increasing to that point, and here I start here and increase again to this point. So we can write the interval, and we did this earlier on last unit. So here, remember this is an arrow, so we're going to start at -infinity. All right, all the way to this point, and we use our x values, and it looks like we're just going to approximate it's at -4. All right, and then here it starts at 2, and then increases to infinity. Now, everywhere else in between these two values, it's decreasing, it's going down. So we're going to say our interval of decreasing is from that -4 to +2. Now, where is something positive? All right, positive means where it's above the x-axis. So I'm going to do this in a different pen right here. So from here to here, it's positive. It's above the x-axis. All right, I'm going to write it on this side. So it's going from -6 to 2. And you're saying, well, why don't I just say to infinity? Well, here, do you see it's 0. 0 is not a positive or negative number. So now what I'm going to do is I'm going to pick back up at 2 and go to infinity. All right, because it's also positive here. It's above the x-axis here. All right, and then it's below the x-axis. That's when it's negative from this point to -6. So we start from the left-hand side and we say negative infinity, and then we say to -6. All right, now I'm going to flip over to page 190. So flip over to page 190 with me. We're going to jump into lesson 5 just right quick and hit some things that we've already kind of hit today. All right, so again, you're going to 190. And we're going to look at two things before we end our lesson. All right, so 190 has these right here. So let's name our x-intercepts, roots, as well as our roots and degree of this. Now, one of the things is, and remember when I said double root. So right here, when I set this equal to 0, we get 0 equal. We add 3 and we get x equals 3. Well, if you notice, do you remember how that square means that there's 2 of these? All right, so this is going to be a double root. All right, and so 3 and 3. All right, so what this means is our degree is 2, but do you see how this bounces off right here? What that means is a double root. Okay, so we're going to continue to actually see that right here. So here, some of you have got it. When you see the x plus 1, you know -1 is an x-intercept. That's a root. All right, here, 3 is a root. Okay, but do you see how it bounces off? So therefore, it's going to be a double root. But we also see it right here because we can write x minus 3 twice. And see x, our degree is 3. All right, now notice this time these both had squares, but do you see how that one has cubed? So it'd be x minus 3 times x minus 3 times x minus 3. So I have 3 x's, so my degree is 3, but this time I only have one root, which is at 3, but it happens 3 times because this parentheses happens 3. And if you notice, it doesn't bounce off the graph. It actually kind of lays on the graph at 3. Okay, it doesn't go through it, straight through it. It kind of just lays down and then comes back up. In calculus, we actually call that an inflection point. All right, and right here, this one's a lone one, so x equals 6. All right, here we know 3, but this one, it's going to happen twice because of that square, so 3 is a double root, and I keep writing that really funny. So here the degree is 3. And you see double root this time, instead of it bouncing off in the positive, this one bounces off in the negative. So that's how you can tell you have a double root when it bounces. All right, so let's look at this activity on page 191, and then we will be done right here. So here, x plus 9, if I set that equal to 0, I subtract 9, and I get x equals 9. We're going to have an x-intercept at -9. Now, x plus 3, set that equal to 0, subtract 3. All right, x equals -3. So I'm going to have one also at -3. All right, and then x minus 4, you're going to actually write that twice, but just set it to equal to 0 once. Some of you may realize, oh, that's just going to be +4, and you're correct. Now, we know it's just going to bounce off. Now, one thing we haven't talked about, which we're going to talk about in the coming days, is the ends and the end behavior. Now, I will let you know, when I go to do this, my leading coefficient is x to the 4th, because I'm going to have x times x, and then x times x, which is x to the 4th. My leading coefficient's positive. So if it's positive, this last thing actually ends up positive. But because 4 is a double root, it's going to bounce off. It's going to hit somewhere right here. We can find y-intercept, but I'm more interested in roots. And then like that. All right. So this is just a sketch of that graph right there. Okay. Know how to find the roots, what a double root looks like, and such, as well as a triple root. But we want to focus a lot more on double roots. Again, if you've got any questions, make sure you're asking your teacher, you're getting help. Make sure you always complete your homework as well.